Hello and welcome to Business Automation Library. My name is Masan, and today we're building an automated competitor price monitoring system using n8n, web scraping, Claude AI, and Google Sheets, all self-hosted on a VPS with Docker. This system automatically discovers new competitor products from a URL you paste in, captures daily price snapshots, normalizes everything on a cost per serving for fair comparison, and then delivers a weekly AI-powered trend analysis email every Monday morning with zero manual intervention and zero LLM cost on daily runs. We'll cover the architecture, walk through the scraper's extraction logic, break down all three end-to-end workflows, and see the complete system running end-to-end. All the files are shared in GitHub, and a full technical guide is also linked in the description. Keeping track of competitor prices is key for any business to stay competitive. This solution provides a method to onboard product URLs like this vitamin to our workflow that tracks daily changes and sends weekly reports of key changes. It's built on a self-hosted VPS with n8n, uses web scraping for data extraction, Google Sheets for tracking data, and Claude for weekly summaries. The scraping side is built to be low maintenance. Rather than CSS selectors that break when a site updates its layout, we extract structured data that's already on the page. Price comparisons are normalized to cost per saving, so you're comparing products on equal footing rather than on sticker price alone. On the AI cost side, daily scraping is fully programmatic with no LLM costs. Claude only runs once per week on a pre-aggregated summary, which keeps the total operating costs under 2 cents a week. This is a good project to follow if you want to see how a scraper sidecar is built into an end-to-end workflow, how to structure LLM calls so they don't add up on a schedule, or how to turn raw time series data into a useful weekly digest. Let's walk through how this system is structured. Google Sheets is the control plane. It holds 4 tabs: products, snapshots, changes, and analysis. The products tab is the only thing you need to interact with directly. Paste a URL and the system takes it from there. Everything else is automated by 3 n8n workflows working on a schedule. Workflow 1 works every 5 minutes, checks the product sheet for any rows where the product ID field is blank. That's our signal that a new URL was added. It fetches that page, extracts the product name, price, servings per container, and serving size, calculates the cost per saving, generates a unique product ID, and writes all of that back to the sheet. Once the product ID is populated, Workflow 1 ignores that row forever. Workflow 2 runs every day at 6 a.m. It reads all active products, calls the scraper each API for each one, and appends a snapshot row to the snapshots tab with that day's price, cost per serving, and availability. There's no AI calls here, so no heavy processing, just clean daily capture. Workflow 3 runs every morning at 7 a.m. It reads the last 7 days of snapshots, computes week over week delta, checks for any changes above the detection threshold, and if changes are found, it builds a prompt for Claude Sonnet, calls the API, and gets back a structured analysis, logs it to the analysis tab, and then sends the email digest via Gmail. The scraper itself is a separate Python FastAPI service running on a Docker sidecar alongside n8n. n8n calls it all over an internal network. It never exposes this to the internet. The separation is intentional. n8n is for orchestration, and the scraper is for all HTTP requests and extraction logic. Keeps the two concerns clear and makes the scraper easy to update independently. So our tech stack, n8n is the workflow orchestrator. It handles scheduling, reading and writing Google Sheets, calling Scraper API, calling Claude, sending email via Gmail. It's self-hosted on Docker. Python FastAPI is the scraper sidecar. It exposes 2 endpoints, one for scraping a product URL, and then one for checking a domain's robots.txt. It's built on HTTPX for HTTP requests, Beautiful Soup 4 for HTML parsing, Playwright for JavaScript rendered pages. Playwright and HTTPX handle the actual fetching. Playwright is optional and it only kicks in if the requires browser flag is set on a product row. Most sites don't need it. Claude Haiku handles fallback extraction during onboarding. If the structured data cascade fails to find a price, Haiku would read the raw HTML and extract what it can. But Haiku only fires during onboarding and when all other programmatic methods fail. So the daily capture is 100% programmatic. Claude Sonnet handles weekly analysis. It receives a pre-aggregated markdown table of price changes, not raw HTML. It returns a structured JSON response with executive summary, significant changes, competitive clusters, and watch list items. Google Sheets and Gmail close the loop. Sheets is a storage and control layer. Gmail is delivery channel for the weekly digest. Before we start building, here's what you need in place. You'll need a Linux VPS with Docker and Docker Compose installed. I'm using a 2 gigabyte shared VPS from Hostinger, which runs about $6 to $10 a month. This hosts both the n8n container and the Scraper API container. You also need a domain pointed at your VPS and an SSL certificate. The technical guide covers setting up Traefik as a reverse proxy to handle this automatically. It's optional for local use, but required if you want n8n accessible over HTTPS. Google Cloud Project in OAuth. You'll need this to set up Sheets API and Gmail API on OAuth 2.0 client ID with the credentials connected to n8n. The technical guide attached would walk through each of these setup steps, and you want to give yourself a good amount of time to get that set up initially. Google Sheets is very simple. You just open a new Google Sheets, and then you add different tab names, and the technical guide will have all of the specific headers that you'll need. Of course, this one is built for tracking vitamin prices, but you can just copy this template and adjust it for the types of products that you want to track. You also need an Anthropic API key or whichever LLM service you would like to use. You can just get their API connection details and insert it where I'm using Claude. The scraper is really the backbone of this project, so let's spend some time describing it. This scraper runs in with 4 tiers in order. So first is the JSON schema.org product. Most e-commerce sites embed a JSON block in their HTML that looks like type product, name, offers, price, and availability. This is the highest confidence source that we're trying to extract from. Tier 2 is meta tags. So sites that don't have full JSON often have open graph or Twitter card meta tags. These are reliable fallbacks that are usually not touched during redesigns. Tier 3 is supplemental facts parsing, so we can use a specific supplement category and handle servings per container. The FDA requires supplement fact panels on all supplement products, and most sites render these as HTML tables with consistent row labels. So, of course, this scraper is kind of built specifically for extracting vitamin prices, but you would want to build your own tiered model for whatever prices that you want to track. Last thing is a Claude Haiku fallback. If tiers 1 through 3 fail to extract either the price or servings, and the allow LLM fallback flag is set to true, then we can send the raw HTML to Haiku. Haiku would return a structured JSON with whatever it can find. Products that hit this tier get flagged with normalization quality set to partial or unresolvable, and a flag that says this row needs review. Daily capture never triggers tier 4. That flag is set to true only during onboarding. Two other things this scraper handles is rate limiting and bot protection. So rate limiting enforces a 5-second minimum between requests to the same domain. This is built into the scraper and runs automatically. And then bot protection is handled with a per product flag called requires browser. If a site uses JavaScript rendering to load its prices, standard HTTP requests will get an empty HTML. So set the requires browser to true on product rows to help the scraper switch from HTTPX to Playwright for that URL, which runs a real Chromium browser to load the page. Workflow 1 is triggered on a 5-minute schedule. The first thing it does is read the product sheet filter and filter for any rows where product ID is blank. If there are no rows, then the workflow exits. If there are blank rows, then it passes it to split in batches node to process them one at a time. For each product, it calls the scraper's robots endpoint with the product's domain. It fetches the robot.txt file to check whether disallows rules block the scraper's path. If scraping is allowed, it calls the scraper's scrape endpoint with allow LLM feedback to true. The scraper runs the full 4-tier cascade we just described. and returns a JSON object with product name, price, serving size, availability, extraction method used, and normalization quality. Let's see all of this in n8n itself. Starting here, we have our scheduled trigger, which then leads to read product sheet. If there are new rows, which is set by looking if the product URL is blank, then we go to a loop where we first extract the domain, we fetch the robot.txt file, we parse that file, we check if scrape is allowed, we'll either update the sheet if it's blocked, or we'll call the scrape API if it's allowed, where we then parse a response, generate product ID, and then update the row in the sheet. Workflow 2 runs every morning at 6 a.m. via a cron trigger. It reads the product sheet and filters to active products only. Scrape allowed must be yes, and normalization quality cannot be resolvable. Products that failed onboarding are excluded from daily monitoring. It stamps the current date, passes the product list to a loop. For each product, it calls a scraper API with allow LLM fallback set to false. The key is cost control in this way. Daily scraping doesn't call an LLM. If tiers 1 to 3 failed, then the scraper returns an error for that product and moves on. This way, your LLM costs don't skyrocket, and you can really monitor the scraping quality on onboarding. Let's see this in n8n itself. It starts off with this daily 6 a.m. trigger, which then sets a run date. We then read all of the active products. We look at the normalization quality filter. If it's not unresolvable, then we set it to a loop where we again edit some key fields that we'll need. We'll call the scraper API. We'll parse that response. If there is an error, then we'll just set the increment error counter to 1 so that we can just log an error has occurred this time. Otherwise, we'll append the extracted snapshot and the product meta. Workflow 3 runs every Monday at 7 a.m. It starts with 2 parallel reads, one for the full products list and one for all snapshot rows from the last 7 days. The code node aggregates the snapshots into per product history. For each product, it takes the earliest snapshot in the window as the baseline and the latest as the current value. It computes percentage delta for price, cost per serving, and availability. So let's see this in n8n. We start off with another cron job every Monday morning at 6 a.m. We're setting a run start date. We read both the product sheet and the snapshot sheet. We ensure both outputs are read, and then we aggregate the snapshots, detect changes. If there are any changes, then we'll append the changes to sheet, and we'll also build a Claude prompt to set off an LLM chain where we invoke the Anthropic chat model. We then parse the response from Claude, build an email digest, and then send a message, which is an email summarizing what's changed over the past week. Now that we've explained all the workflows, let's actually see it in action. So this is our Google Sheets. We're on the products tab and we see there's a bunch of rows where product ID is blank. So this will be the trigger for our onboarding to initially track all of these product details from the URL. So this first one we can see is on this tab and it's set at 1350. And we can see all these details here. So let's see if the scraper is able to extract this. We go back to the onboarding workflow and we'll just execute this. So it should run about 10 times for all of the blank product IDs that we saw in that sheet. We'll hit execute and we see the workflow starts to run in the loop. Let's go back to the sheet and we already see data being pasted in here and probably we can see some being written live. And we verify that this first link extracted 13.5 and I'm sure it's true for the rest as well. So let's actually check this. This one says vitamin K2 is $75. So let's just look at this in a new tab. Okay, that looks true. 75 for 1,200 drops. So this first workflow definitely works. Next, let's test the second workflow. So we're on the snapshots tab now, and let's sort this so that the latest snapshot would show up. So we see there's a couple snapshots already from today. But let's see, now that we have new product IDs in this sheet, let's see if the snapshot will run and generate daily snapshots for those specific products. So here we're on the daily capture workflow. Let's execute that and see if the daily snapshots show up for those new products. So again, I'll execute this workflow. We'll go back to this sheet and we should see new snapshots show up on the bottom or top. Okay, we're starting to see new snapshots show up for all of those products that we just set in here. The last step is the actual notification that gets sent every Monday. So this would theoretically, we've been running this for 7 days. Now let's check if Claude, first of all, if any changes are detected. And if they are, then let's get the Claude summary in a nice formatted email. So we'll execute this workflow, runs through. We could also see changes appended to the changes sheet. The model invocation will take a bit of time just to process the prompt. We see the workflow has now executed successfully. So now we can see the competitor pricing digest changes off of our products that we had in there. So this is tracking those three first products we had. If we just enabled it for 10 new products, those won't have the 7-day history, but these first three will have what we need. Now that we've kind of proven the system works, let's go over what this replaces and improves. So without automation, monitoring 5 competitors or however many you want to track across different product categories means opening these different URLs every single week, copying the prices into a spreadsheet, doing the cost per serving math yourself. Of course, you probably wouldn't do that, but just showing you what it would seem like manually. With this system, adding a new product is very simple. We just import a new URL. The daily capture is automatic. The cost per serving normalization can be built in. And then change detection runs on a consistent baseline. And you can change whenever the notification comes and the thresholds of which triggers that notification. So this is just a nice system where you can really set up any sort of competitor tracking or price tracking, maybe even something in your personal life, a product that you want to track different price changes to for different websites, you can set that up. In terms of cost, times, and skill, this is a very low cost project. The most cost would be running your VPS, which is probably, $6 to $10 each month. Everything else is fairly cheap because we're building reliable web scraping, and we don't want to invoke an LLM for every single small task. We're just using it for the summarization part. So the actual cost of running will be very low. It will take a good amount of time to build this. If you're setting up a VPS, a Docker container, SSL setup, setting up your Google Cloud authorizations, enabling APIs. And then building all of the n8n workflows would take some time for sure. I'd say this is around an intermediate level project because you just have to be somewhat familiar with working within the VPS, Docker, building n8n nodes, setting up credentials. The Python scripts are basically enabled via Claude Code. I mean, you don't really need to spend a lot of time doing that. And then the Google Cloud authorization step might take you a couple of times to get through all of the things that hoops they make you jump through. So let's just recap what this system. So let's just recap what this system gives you. So the selector-free extraction, JSON, and supplement facts survive site redesigns without maintenance, right? So if they change things up, it'll still stay somewhat consistent. This has three independent workflows: onboarding, daily capture, and weekly analysis. Each run and fail independently. There's almost zero daily LLM spend. Claude only touches pre-aggregated data once per week, keeping costs near zero. Of course, you could change this in your own project. I'm just saying that we're relying more on the reliable web scraping extraction rather than trying to brute force everything through a prompt. Auto onboarding. So all we need to do is upload a new product URL, and then all of the extraction will be handled from there. And then also we're working on normalization. So of course, all of these different product URLs have different serving sizes, and we need to break that down into a cost per serving, which is built into this analysis as well. Thank you so much for watching this project. All of the code is linked in the GitHub repo. The technical guide is also set up to walk you through every step from VPS setup to the first email digest. If you run into issues, there's a troubleshooting section as well that covers the most common failure points. If this was useful, please subscribe for more automation builds. New projects are dropping around every 2 weeks across any automation platform I can find that's interesting and solves real world use cases. Thanks for watching.